fish are being introduced into the man-made lake. The change in rate. So right there means this is a derivative, a slope. The change in rate of F, the number of fish. So that means we got df, d something with respect to t. So that means the rate of change in the fish with respect to time is directly proportional. Again, that directly proportional is that k deal again, times 900 minus f. So what I'm going to tell you again is, we did a bear problem that was just like this. So this 900 is the most amount of fish you can have in that lake, because you can't have negative fish. So that 900 is the answer to this thing. That's the limit as f goes to infinity. I just said that, so it should be t time. Okay, so that's it. All right. So I'm going to go ahead and finish this because I screwed it up when I did it the first time. So this says, write and solve a differential equation that describes this situation. So I got to go back up and get down my ordered pairs up here. It says when time is 0, in other words, when they started the lake, they put in 400 fish. 3 years later, there were 600 fish in the lake. So we want to figure out all this good stuff about this. So we're going to solve this thing and be done. So I've got to get all my capital F on the left side. So I got to divide that 900 minus F deal right there. And then I got to get my t's on the right side. So I got to multiply my dt over. And I'm going to do integral on both sides. So this is extremely like the bear problem we just did, very similar. So over here, I got to do u substitution. So u is going to be 900 minus capital F. So du is going to be a negative df. So what's missing is the negative. So I must create and destroy a negative. So it's going to give me negative integral of 1 over u du. And over here, when I do the integral of 1 with respect to t, that's going to be kt plus some c. Now I'm going to get rid of that negative by multiplying both sides by negative 1. And I'm going to go ahead and integrate this, which is the natural log of u times the negative kt plus some c. Now that c's a different c than that one because I go distribute the negative. And then I want to put in this 900 minus f that I let u be again back down in here. Minus f. So this is almost identical to the bear problem, except the bears weren't 900. Okay, so we're going to get e on each side. So these natural log and e cancel, so I got 900 minus, and if you want to change this to f of t, because that's what the function's about, the fish with respect to time. And then this will be e to the negative kt power times e to the c power. Well, this e to the c power is just the new c. So I like putting that c in front. You don't have to, but I think it makes the problem easier. That's why I do it. You can leave it this way over here. You can even leave a negative kt plus c, but that makes solving for c harder. This makes solving for c easier. So now I'm going to go up here and use my original fish. At times 0, I had 400 fish. So I'm going to, and this is where I screwed up on the video. I did not plug the 400 in right here to f of t. So when I did the notes first time, this was wrong. It should have been 900 minus that 400, and then CE. I'm going to plug 0 in there. 0 times k is still 0, so that's 0. So C equals 500. So there's my C. So I'm going to, right here's where I plugged in all my numbers to this function. So this is where I plug my 500 back into C. So 900 minus f of t is going to equal 500, because I'm going to plug that in for the c, e to the negative kt power. Now what I want to do is find k, the direct proportionality, direct proportionality change. So now I'm going to take my other point, 600, and plug it in and find k. So 900 minus 600 is going to equal 500 e to the negative k times 3. Plugging that in for t. So I get 300 is going to equal 500 e to the negative 3k power. I divide by 500 and get 3/5, or you can put 0.6 if you want, is e to the negative 3k power. Then I got to get rid of e, so I have to natural log this side. I have the natural log this side, and those two things cancel each other out. So I got negative 3k over here equals the natural log of 3/5. So k is going to equal, multiplied by negative 1/3, the natural log of 3/5. So there's your k. So now I'm going to take this k value, and I'm going to come up here and plug it in for that right there, because right here's where I plugged the 3,600 in, was into this thing. So my function is going to be 900 minus f of t is going to equal 500 minus e to the k was negative 1/3 natural log of, I'm going to change that to 0.6 so I don't have to write so much. T, there's my equation. Now I can simplify this more. Okay, you want me to show you that we can simplify it more? Or, okay, I'm just going to leave it like that then. So now what I want to do is plug this 300 in here. Now you may want to solve this for f of t first, because that's what we're looking for. So I would subtract 900 first and then divide by this negative 1. So when I subtract 900, that's going to be negative 400. But when I divide by negative 1, that makes it positive 400. And that's going to be a minus, I'm going to do the step here. I'm going to do it wrong. All right, so I'm going to subtract 900 from both sides. So our negative f of t is going to equal negative 400 minus e to the negative 1/3 natural log of 0.6 t. Okay, and then that's going to be divided by negative 1 on each side, or multiplied by negative 1. It's 400 plus e to the negative 1/3 natural log of 0.6 all times t. This whole thing is different. T does not go with the natural log. So now I want to find f of 3. So I'm going to plug 3 in up here where this t is. Okay? So you type this all in your calculator, or we can do this even faster. 3 1/3, 3 times 1/3 will reduce that to negative 1. I might be able to do this without a calculator. So that'd be negative 1 natural log of 0.6. And then I'm going to take this negative 1 and bring that up to the power of 0.6. I'm going to change it back into a fraction. So it's going to be e to the natural log, and this is 3/5 again. But that's all raised to the negative 1 power, which means you got to flip the fraction upside down. So this is 400 plus, these two cancel out, I got to flip that upside down 5/3. So it's like the population, well, that doesn't make sense. I put a number in wrong somewhere. 300. I wonder if I did something wrong in my head. This does not make sense, but there'd only be 401 2/3 fish. I must have made a mistake somewhere up here. Let me see. 3/5. That's right. 3/5. Natural log, -3, so all that's right. 900 minus up to 500, and negative 1/3 natural log of 0.6. That should be right. Subtract 900 by negative 1. Would somebody take their calculator and type it in with this thing right here? Let's see what that comes out to be. It looks like I may have made another mistake by accident somewhere. I'm going to look real quick. What? Minus. Okay, so over here, this was 500 times E. Okay, times E, it's times E all the way down there. And when I came over here, I changed it to a minus because of that little mark there. So you gotta be able to read your own writing. So this minus sign should not be a minus, that's a time. So this is not right here. We need to go back and fix this part. So I had to subtract 900 right here. So when I subtract 900, I was times 500 e to the negative 1/3 natural log of 0.6 times t. I'm going to move that t over here on the top and make that negative t over 3 by multiplying those two. Okay, and then I have minus 900, and then when I multiply each side by negative 1 to get rid of that, I get a positive 900 minus 500 e to the negative t over 3 natural log of 0.6. Okay, because I can't read my own writing, I got it wrong. So this would end up equaling 900. Let's see, you're supposed to plug a 3 in. You got to plug a 3 in right here. Plug a 3 in for that t, so that makes that the negative 1 power. So this is 900 minus 500 e to the negative natural log of 0.6 power. So this is 900 minus 500, and then I can bring this negative power up here to this being the negative 1 power, and this is 3/5. So these two things cancel out right there. So this is going to be 5/3 flipped over like that. So whatever this ends up equaling should be your answer. Come on, tell me what 900 minus 500 times 5/3 is. Real quick, calculate. 600 and about 67 fish should be in the lake then. Yeah, 0.7, right? I just rounded up. 0.6. Now you can round that up if you want, but should be something like that. Okay. All right. So I will see. I'll be around and spray your desk.